Dr. Denton, what was your motivation for writing Evolution, A Theory in Crisis?
Very simply, I think the current Darwinian picture is insufficient. I don't think it gives a credible and comprehensive explanation of how the pattern of life on Earth emerged. And I think that it's a perfectly normal and ordinary response that when you think something isn't right, you attempt to refute that body of doctrine or whatever it is. I mean, it was basically because I felt that the theory was incomplete and didn't give a good explanation of all biological phenomena that I was motivated to write the book.
Why should students be exposed to problems in evolutionary theory?
Well, I think any theory which is where there are problems, one should be exposed to these problems. I mean, theory shouldn't be taught as absolutes, like theological doctrines. Where there are problems, people should be exposed to them. And particularly when theories are very important, such as the theory of evolution is. This is a very important theory, which permeates a lot of our thinking now in the Western world, in the modern West. And if there are problems with the current Darwinian worldview, then I think that these should be discussed. And I think there are very serious problems.
What have been the major objections to your book, Evolution, A Theory in Crisis?
Most of the objections have been vague and philosophical. I mean, of the many reviews that I've read very carefully, and that I've looked for specific objections, I don't find many specific objections. I mean, most of the objections are that, in fact, this guy's a creationist, or he doesn't believe in Darwinism, he's sort of outside of the mainstream of biology, and so forth. They're not the problems that I have with evolutionary biology, particularly the Darwinian model of evolution, and the ones that I described in the book. I mean, most of those specific problems, and some of them, of course, which have been aired by many authors over the last century, are not really addressed. The attack is mainly of a philosophical and non-specific type of nature.
Does Darwinian theory adequately explain the pervasive patterns of natural history?
Well, the basic pattern it fails to explain is the apparent uniqueness and isolation of the major types of organism. My fundamental problem with the theory, I have a number, but perhaps my major one is that, in fact, there are so many highly complicated organs, systems, and structures, from the nature of the lung of a bird, the nature of the eye of the rock lobster, and one can mention many, many cases like this, where there are structures, systems, adaptive phenomena in nature of such a nature, such exquisite complexity, watch-like systems, if you want, for which I cannot conceive how these things could have come about in terms of a gradual accumulation of random changes. I mean, it strikes me as being a flagrant sort of denial of common sense to swallow that all these sorts of things were built up by cumulative small random changes. I think that, in fact, something within me, my judgment is that in terms of deep common sense, this is simply a nonsensical claim, and especially when, in the great majority of cases, most of the complex adaptations, nobody can think of any credible explanation of how they came about. And this is a very profound question, which everybody skirts, everybody brushes over, everybody tries to sweep under the carpets. The fact is that the majority of these complex adaptations in nature cannot be adequately explained by that their emergence occurred via a series of intermediate forms. And this is, in fact, something which, in fact, as far as I'm concerned, this is a fundamental problem. And the fact that there are so many of these things, for me, okay, there's something wrong with the theory. Common sense tells me there must be something wrong.
What, in your judgment, are the most serious objections to Darwinian theory?
Well, the first problem that I have, the first most serious objection to it, is the question of the nature of mutation. Now, as you know, that Darwinism is based on the idea that all the mutations which have been selected during the course of evolution were, when they initially occurred, entirely random, were never of any adaptive use to the organism. And this is the doctrine of the what you want to say, the non-adaptiveness of mutation. In other words, mutations are random, and when an organism has a mutation which in fact is advantageous to it, or that's purely fortuitous. Okay, so when an advantageous mutation occurs, it's fortuitous. This is the essential bedrock of Darwinism, that the mutational input into living things is, as it were, random. Now, the problem with this doctrine is that mutation is something we don't know much about. I mean, my own field is human genetics. And while I certainly accept that the deleterious mutations which occur in humans and cause human disease, I'm prepared to accept that they're random. But what I don't know about is the vast undercurrent of mutations which we don't really see, which may be neutral, which may have no particular deleterious effect and may not be particularly advantageous. And then there's the possibility of advantageous mutations occurring in nature, which we don't really know about yet, you see, or know nothing about. Mutation is a mysterious thing. And there's been recent work done by some people working in microbiology, which suggest that in some microorganisms, advantageous mutations may actually, as it were, be written in the genome by the organism itself. Now, this is a bit controversial. Now, I'm not saying that, in fact, sort of the idea that advantageous mutations can be, as it were, directed by the organism itself has been shown or proven, but there's been discussion recently, in the last few years, in scientific literature about this question. But what this discussion has revealed again, of course, is the mysterious nature of mutation. Now, when you come to the Darwinian claim that the whole tree of life grew from an input of random mutation, and what was selected, which was advantageous, was at its initial occurrence pure fortuity, this is a claim which is entirely, utterly unsubstantiated. It is impossible to say that the mutations, for instance, which led to the evolution of A or B or man, were built up during the course of time by the accumulation of mutations which were, as they initially occurred, entirely random. That is absolutely an unsustainable position. Mutation is a mystery. The claim that mutation during the course of evolution, the mutations which drove the tree of life, were in their initial occurrence in the organisms random, is absolutely unsubstantiated. And yet it's the foremost plank upon which the whole Darwinian edifice is based. And it's very interesting that after the recent discoveries in microbiology, that in my own university department where I'm working, there was a big flutter went through the orthodox Darwinists and evolutionists in the department, because they said, hey, supposing mutations can be directed by an organism towards its own advantage, supposing in fact the doctrine that mutation is always random isn't right. But as I say, the evidence isn't in on this, but it's a terrible reminder of the fragility of a claim that all mutations, and let's repeat this. Darwinism is claiming that all the adaptive structures in nature, all the organisms which have existed throughout history, were generated by the accumulation of entirely undirected mutations. That is, an entirely unsubstantiated belief, for which there is not the slightest evidence whatsoever. And moreover, it may be that there will never be that evidence, because those mutations occurred in the distant past, in genomes which have now disappeared, forever perhaps, from the view of man. That's the first problem. So the first claim, that random mutations are selected and create different forms of life, can't be sustained. The second problem is that getting a vast number, and we've already touched upon this earlier, there are a vast number of complex systems in nature, and no matter how unglamorous this problem is, and no matter how people try to look the other way, the fact is that a huge number of highly complex systems in nature cannot be plausibly accounted for in terms of a gradual build-up of small random mutations. Indeed, in many cases, there does not exist in the biological literature even an attempt to explain how these things have come about. A classic would be the lung of the bird. And I could mention some other ones, but everybody knows that the lung of the bird is unique in all vertebrates in being a circulatory lung rather than a bellows lung. And I think it doesn't require a great deal of profound knowledge of biology to see that an organ, which is so central to the physiology of any higher organism, its drastic modification in that way via a series of small events is almost inconceivable. This is something we can't throw under the carpet again, because basically, as Darwin said, if any organ can be shown to be incapable of being achieved gradually in little steps, my theory would be totally overthrown. The fact is that in common sense terms again, in terms of common sense, if you have no axe to grind, there are a vast number of such cases in nature. So the two serious objections are the assumption of randomness, unsubstantiated, the claim that gradualism can generate the sorts of complex systems we see throughout the biosphere. As again, not only is it unsubstantiated, but in many cases I think it's actually beyond the realm of common sense that such things would ever happen.
What do you feel are the strengths of Darwinian theory?
Its major strength is that, in fact, small-scale biological change can be adequately accounted for by Darwinian mechanisms. You have the case of the peppered moth, and you have other sorts of cases where it's demonstrably true that natural selection has created a biological change. And the transitions, perhaps in the history of life, such as those minor ones which lead from the early horse to the modern, from the five-toed horse to the one-toed horse, can perhaps be adequately explained in terms of gradual evolutionary change. So that Darwinism does explain a certain degree of biological change. I think there's no doubt about that. I certainly believe that natural selection is capable of generating change in nature. After all, artificial selection in the hands of man has generated considerable change in domestic animals and domestic plants. So I don't think there's any doubt that a small degree of evolutionary change can and does occur, and certainly that such change could be generated by natural selection to a large degree, that natural selection could be the major factor in moulding these changes. And I think this is a great strength of Darwinism compared with its competitor explanations. I mean, after all, if you're going to reject natural selection, the accumulation of the selection of random mutations as the major cause of evolution, you've got to find an alternative. Well, there's Lamarckism. There's various forms of teleological theories, extending from sort of the creationist intervention theories all the way to sort of almost nature mysticism. But these theories are more of a sort of, I don't want to be derogatory, but they're more of an occultist type of theory. I mean, you can't really find any evidence that such phenomena are operating in nature, but you can see that natural selection can operate. Hence you have artificial selection, and you have natural selection, and you know that natural selection works. This is a great strength of Darwinism, because although I think it's totally incapable of accounting for the broad sort of picture, I don't think it's generated the tree of life. I don't think it generated the complex adaptations. But on the other hand, I think that it is certainly capable of generating a certain degree of evolutionary change, and that's its great strength. And I would certainly concede that it is a strength of it. As a working scientist, you like to have evidence that the mechanism you're proposing will work at least in some case. So that's a major strength.
Is it possible that random mutations in natural processes are insufficient to account for all biological information?
I just don't think it's credible that the accumulation of small fortuitous changes can lead to certain of the most complex adaptations we see in living things. I don't think the transformations, for instance, during vertebrate evolution of the various gill arches from fish to mammal, I found that sort of level of transformation generated by small random changes quite incredible. I find highly complicated adaptations for which nobody has ever imagined the intermediates in reality existing. I find that, in fact, in those cases, again, I find it incredible. I think that, in fact, basically, I do not believe that common sense allows you to believe it, as it were. And I think that, in fact, if you were a Martian and you came from Mars and you were shown a thing like the avian lung, and you said, well, how did this come about on Earth? And an orthodox biologist came along and said, well, basically what happened was that reptiles underwent, as all organisms do, slight changes, and slowly, in some way, the traditional in and out bellows lung was gradually converted to the circulatory lung of the birds. And I think that the Martian would have some problem first being presented with this explanation for believing it. In fact, he wouldn't believe it. The reason why biologists believe this explanation is because they haven't got another explanation. And there's a saying that, in fact, the intellect abhors a vacuum. But the fact is that that is not the explanation how it happened, and it's incredible. And looked at, as it were, from a Martian point of view, it's obviously absurd. And there is no doubt that in the history of life on Earth, that is not how it happened. It wasn't built up gradually by little gradual accumulations.
Is it possible that natural processes exist which prevent major evolutionary change from occurring and which account for the natural phenomenon of stasis?
Well, I can see why organisms might remain unchanged fundamentally through thousands or tens of thousands of generations because of the sheer complexity of living things and what I call the integrative complexity of development in the genome. And what I mean by this is that, in fact, many genes play a role in many systems, and nearly every system in an organism is generated by the interaction of many, many genes. And there is also in organisms a colossal amount of redundancy. That is that the same developmental end or goal is achieved by the interaction of not only a vast number of different systems, but sometimes in different ways. In other words, you can actually take out one particular part of the organism and it still reaches the goal somehow, because there's a redundant sort of information there which drives the organism to its goal in many different ways. In other words, there's different ways of getting to the same goal, and there's generally many operating in an organism. So you've got the fact that the whole genome sort of is an interactive whole, and in development you have the interaction of surface tension with proteins on the cell surface, with developmental systems. I mean, the whole thing is so holistically integrated together that trying to imagine major change is extremely difficult. This is a problem in classical evolutionary biology called developmental constraint problem, genetic constraint problem. I think it's a very real problem, and I think that in fact the fact that there is stasis is easily explained in terms of this colossal restraint that must be imposed on organisms by this integrative complexity within their genetic and developmental makeup. So I think that there is an explanation for that, yes.
What natural processes might account for higher taxon-level stasis? Why have no new phyla originated since the Cambrian?
Well, I've sort of, to some extent, the previous question, where you discussed the general phenomena of stasis, may well account for the fact that major changes in the structure of organisms don't occur. So to some extent, once again, I think it's the integrative complexity of higher organisms which imposes basic restraints against major innovative change. So that might be one of the reasons why the fundamental body plans of organisms which evolved in the Cambrian time have remained roughly unchanged. Why there have not been new phyla evolve, as it were, for the last several hundred million years, may well be that, in fact, the existing phyla have filled virtually all conceivable ecological niches, and the competition is intense, and the idea of a radically new organism sort of finding room to get going has perhaps been sort of that possibility sort of been closed. I mean, nature's closed the door, as it were, on significant innovation, and the existing taxa being so complicated from Cambrian times down, couldn't undergo fundamental body changes in their body plan because of the developmental and genetic constraints, the complexity problem we've already discussed. And sort of on top of that, the severe competition and the filling of all ecological niches may well have meant that no genuinely new form of life can get going.
What are the major problems with current origin of life scenarios? What are the major obstacles yet to be overcome?
One of the major problems with current origin of life scenarios is that nobody can imagine, or nobody's worked out a way of getting an aqueous pool of water containing all the amino acids, all the sugars, all the bases, all the building blocks you need to make a cell. This is a fundamental problem and poses huge chemical and physical problems as to just how on earth the so-called prebiotic soup could have been generated on a planetary surface. This is not known, it's not solved. That's problem number one. The second problem is, and obviously I can't go into great detail here, but the second problem is how you get from a soup of organic compounds all the way to the cell through whatever route you've tried to imagine. And that's the problem. No real route's been imagined. It's not so much an obstacle as a sort of an awesome problem in science. All I would say to that is that in fact the obstacles amount to something which are perhaps collectively as big as all the other problems in evolutionary theory put together. Getting from that soup to the cell is a colossal problem. Imagining how the soup was actually synthesized in the first place, even that hasn't been solved. And that is also a colossal problem in itself. The whole area of the origin of life is a profound mystery. It's a big enigma. And at the moment it's not clear at all how living things first emerged on Earth, or even if they did emerge on Earth. You may speculate they emerged in space or another planetary surface. The problem is not solved, and there's not even a straw in the wind, I think. Even the RNA story, which has recently come out about the RNA world, its relevance is vague and uncertain. And there are many critical reviews in this area which have been published recently. It's a big problem.
Has the problem of chemical chirality been solved?
No, it has not. What this means is that, in fact, many of the building blocks which make up living things rotate life in a specific direction, polarize light in a specific direction. And one of the problems of the origin of life, which is what this question refers to, is that how come all the amino acids used in living things rotate light in a particular direction? Because if you synthesize amino acids randomly in a prebiotic sort of simulated environment, you get amino acids, a mixture of 50% of the amino acids rotate light in one direction and 50% rotated in the other direction. Whereas all the building blocks of living things only rotate the amino acids in one direction. And it's very difficult to see, for instance, how proteins could ever have, as it were, developed biological properties if they were made up of a mixture of, as it were, left and right rotating amino acids. In other words, you'd have to start synthesizing them from only one sort of amino acid. So the answer to that is that there's no way in which, in fact, there's no scenario, no credible scenario ever been presented or imagined that will explain how it was that only one set, right, only those amino acids which rotate light in one direction were selected from, as it were, a random mixture of amino acids which contained 50% which went one way and 50% which went the other way. Somehow, before you could have the origin of life, you're going to have some way of sorting these things out. And the problem has not really been solved. However, these things are interesting in a sense that it's an interesting question because there could be, perhaps, who knows, there could be some very simple explanation. There could be some very simple way of making that separation. But at the moment, we don't know how this happened. But it would have to happen before life could get going.
What are the primary reasons that Darwinian theory is still widely accepted by the scientific community?
Throughout most of the last century, there have been a large number of leading biologists like Grasset that have never accepted the Darwinian explanation of evolution. Indeed, on the continent of Europe, probably until shortly after World War II, you could say that the majority of biologists were not Darwinian evolutionists. The reason why Darwinism is prevailing today, despite cogent reasons and despite its inefficiencies and despite the fact it doesn't give a credible explanation for things, and I certainly think it's ineffective in so many ways, the point is that it's the only explanation which comes remotely close to being able to explain things. rather in the same way that when you look at a complex scene, the eye imposes a pattern on it. The eye sees something. The eye attempts to interpret things. So it's like this in science. Science abhors a vacuum. We like theories. And we like theories which explain things. And even if the theory has glaring holes in it, and just like and insufficiencies, just in the same way that the eye imposes a picture, a pattern on some dots or a complex scene, and although the thing that you see is only a vague representation of the actual thing that's out there, so it is with scientific theories, and particularly the Darwinian theory of evolution. I mean, it explains bits here and there, and it's a partial explanation. It'll sort of do, and there's no alternative. And when there's no alternative at the moment, apart from perhaps Lamarckism, but then what's the evidence for Lamarckism? Perhaps there's some evidence recently in microbiology, but it's not very clear. And what evidence is there for other factors which could have caused evolution? Well, very little. And so that in this situation, no matter what the problems are with the scientific theory, there is at least one theory which we've said previously explains small degrees of change. We know this. And it gives a vague, approximate explanation for the history of life on Earth, and so it'll do. It'll do till something better comes along. When something better comes along, it'll be dropped. Because there are huge problems in it. And as far as I'm concerned, it's almost certain to be an incomplete explanation for biological phenomena.
What are the primary reasons that creation is rejected as an alternative to the general theory of evolution?
The theory of specific creation involves the direct intervention of God in the course of events. This would necessitate throwing up the basic goal of science, overthrowing the goal of science, which is to demonstrate a natural explanation and find natural laws responsible for phenomena in the world around us. And it's completely foreign. The idea of, creation implies the breaking of a law. And it's completely foreign to the idea of science, that natural laws are ever intervened to or ever fiddled with by a god or anything else. And this has been this case since Newton down. The science is in the business of finding natural laws, natural regularities, things which hold for all time in all places. It's not involved in unique or special events of that sort. Science can say neither. It can make no comment, nor can it experience such events. They're outside the realm of science. So the reason why science science I don't think would ever accept that as an explanation. It would run counter to the whole spirit of science, which is naturalistic and legal, and implies a universality to law, which creationism implies as broken by God at his will. The other thing I might add is as well that to some extent it's there's something intellectually unsatisfactory, even from a theological position, that God has to intervene in the history of the world to change his laws, to bring forth life. After all, the laws that hold universally throughout the cosmos, as far as we know, why did the same lawgiver break the laws to get life? I mean, there's something intellectually unsatisfactory about that. It doesn't look like a great unity. There seems to be something. Now that, of course, is just the feeling of modern science, but I think most scientists would also feel that. Most scientists that were religious would feel, surely God doesn't have to break his laws to create life. Those life-giving laws which generated the cosmos, surely they wouldn't be interfered with to create life. Surely those laws would generate life, you see. So science is wedded to a naturalistic conception of the world. And this would be my position as well, that however evolution's occurred, it would not involve the breaking of natural law. But I happen to know that there is almost certain to be out there a huge number of regularities, subtle regularities in the order of things, which we know nothing about, which may well have played a big role in evolutionary change, in generating evolutionary change. But I go along with the scientific community's prejudice in this instance as well, that I can't accept a creationist explanation for evolution, except as a last resort. I will push naturalism to the limit. And I don't think that limit's been reached, and I think that will be the view of most people working in science.
What would you most like to be remembered for?
If I was to be remembered for anything, I'd like to be remembered as one of the biologists in the last century and a half which spoke out against the theology of Darwinism. I profoundly believe that this explanation is not the complete explanation for biological phenomenon. And I am absolutely certain that this will be acknowledged universally at some time in the future. It may be we'll have to wait into the next century, but I'm sure that it's wrong. I'm sure that it's an incomplete explanation. There are other factors at work in biology which have generated and have been largely responsible for the growth of the tree of life and the generation of biological adaptation. I don't know what those factors are, but I'm sure they're there, and I want to be remembered as one of that long line of biologists that have at least attempted to, as it were, to raise a voice, to be a voice in the wilderness against the prevailing paradigm of Darwinism. And hopefully, in fact, through reading my book and hopefully the next book I'm writing, one keeps alive this flame of dissent. That's all.
What are your future plans?
I'm hoping to find the cause of the genetic eye disease that I'm studying, which is one of the commonest forms of inherited blindness in man, a disease called retinitis pigmentosa, which most people really haven't heard of, but it actually causes blindness in about 1 in 4,000 humans. So it's a relatively common genetic disease, and it's the commonest form of, as I said, of inherited blindness. I'd like to find some of the genes responsible for this disease. The second thing I'd like to do is I'd like to write another book on evolutionary biology, not from an anti-Darwinian perspective. It won't be pro-Darwinian, but from a quite different perspective, looking at the nature of life in the context of the cosmos, and looking at it from the point of view of whether or not the laws of nature may well have generated living things as we know them, and that life may be a determined and necessary outcome of the nature of things itself. This is a complicated issue which requires another tape, another video, some other time.